on the handout, on this handout, we're going to go over this stuff again. Write stuff down as I go over it. Put it in your binders where it belongs. It's dealing with conditional statements and a bunch of other stuff that the homework that you had last time went over. If you follow along, you should be able to find this on the one page of the handout. Then we'll flip it over to the back page, do some stuff on that. Then we'll flip over to the third page. A statement is any sentence that is either true or false. You make a statement, the sky is orange. Then it could be any statement. Doesn't have to be true, doesn't have to be false. It's just a statement. The truth value is telling whether that statement is true or false. So when we go to take a test over this stuff and it asks you to find the truth value, don't make it harder than it is. All truth value is asking you is to tell whether the statement is true or the statement is false. A negation. On negation, make sure you write this down. As I get my pen up here. On a negation, all a negation is making the statement the opposite of what it was. Okay? So if I give you a statement, and I'm going to use this a lot this chapter, when you have something like your statement is just P, the reason I use that is why. Anybody have a guess? Instead of actually writing out a statement?
A lot easier.
It's a lot easier, it's short, I'm lazy. Alright? So, and the book uses stuff like this a lot. Do we have any idea whether that statement P is true or false or anything else? No clue. Does it matter? If they wanted you to tell whether it was true or false, then they would have gave you an actual statement that you could make a decision on. So if our statement is P, the negation of that would be not P. This is the symbol for a negation. So anytime you see this symbol, it's going to tell you not something. It's just a little tilde. You have to use in Spanish class over, what's it over, N or something in Spanish. It's just a little tilde. So if you see this, not P, that's how it's read. A compound statement. If you're in English class and you're making compound sentences, what kind of words do you use? And, because, is that what they're called now? Fanboys.
Fanboys.
I have no idea.
I heard somebody else say that yesterday, so that must be something that they're teaching now somewhere. What's the other word?
I don't even know what we're talking about.
I heard somebody say it.
Or and yet or but so.
Conjunctions also, right?
Oh, conjunction. Oh, yeah, conjunction.
I heard somebody singing that little Saturday morning song on the cartoons. So conjunction, now it's a little different in math class. Conjunction in English class, a conjunction word is and, or and, or, but, all those different words. A conjunction in here, if you hear conjunction, it only refers to the word and. So anytime you have a conjunction, you're using the word and. So if I say this and that. Now for a conjunction, in here, for a conjunction to be true, and I use this as an example. If I tell you, if my statement is, I am going to go to the grocery tonight and go to the movies. I come back next week when I see you again, and Chase says, did you go to the grocery and the movies? And I said, nah, I just went to the grocery. Was my original statement true or false?
True.
False. Because when you use the word and in there, and I tell you, I am going to go to the grocery tonight and I am going to go to the movies, and I come back and I tell you I just went to the grocery, did I lie to you? Yeah. I didn't tell you the whole truth, right? So it's just like with your folks. If you said, hey Mom, I'm going to go over to John's house and then I'm going to go take out the trash, and you come back and you tell your mom, yeah, I went to John's house. Did you take out the trash? Oh, no. Then did you lie to your mom? Yeah. And would your mom take it as a lie? Yeah, you were supposed to take out the trash. All right? So whenever you use the word and, both halves have to be true for the whole statement to be true. All right? A disjunction. Disjunction uses the word or. Right? A disjunction uses the word or. When I say, I am going to go to the grocery tonight, or I am going to go to the movies, and I come back next week, I come back next week and I tell you I went to the grocery. Did I lie to you this time?
No.
No, because I told you I was going to do one or the other. You just need to.
Oh, you're free.
You're welcome. So with a disjunction, only one or the other part has to be true for the whole statement to be true.
Compound.
So a compound statement could be a disjunction, could be a conjunction. Conjunctions use the word and for that statement to be true, both parts have to be true. Disjunction uses or. Only one or the other has to be true for the whole, for the whole thing to be true. Truth table. This is what Joseph was asking about earlier. We're going to talk about that here in a minute. We're going to do some truth tables. Not near as difficult as you thought they were as you were doing it. All right? And it just decides whether a statement is true or false. Now, it's going to go through and use statements like P. You ever going to be able to decide for sure that P is true or false? No, because you don't know what it is. All right, conditional statements. This is probably the most important part of all these notes. Dealing with conditional statements and dealing with these three ways of changing conditional statements around. A conditional statement, another name for a conditional statement, is an if and then statement. And this is probably the most important because I know for sure that on the final exam, there's at least two questions that deal with this stuff right here on this page. One of them is a multiple choice question, and it says, a conditional statement is also known as a blank, and then it's multiple choice. Well, a conditional statement is also known as a if and then statement. And the reason it's called that is because you're going to see those two words every time you have a conditional statement. If something, 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 then something, something, something. All right? The if part is called the hypothesis. The then part is the conclusion. So if I'm looking at this right here, which it got messed up on me when I put it on this slideshow. If I'm looking at this statement, if it is raining, then the grass is wet. What's the hypothesis there?
It is wet.
It is raining. All right? So that's your hypothesis. What's the conclusion? Grass is wet. Okay? That's all it is. This is your hypothesis. It is raining. That's your hypothesis. The grass is wet is your conclusion. What's the hypothesis in this next one? If P, then Q. What's the hypothesis?
P.
P. What's the conclusion? Q. All right? So hypothesis, conclusion. Next one, if two angles are vertical, then they are congruent. What's the hypothesis there?
Two angles are vertical.
Two angles are vertical. That's the hypothesis. Conclusion is They are congruent. Right. Converse, inverse, contrapositive. Make sure you write this down as I write it down on here. It's going to help you to understand this. Again, there's a question on the final exam deals with these three things where you got to take a sentence and change it into the converse, the inverse, and the contrapositive. The first one, converse. If your original statement is if P then Q, the converse of that is if Q then P. What did it do to get the converse? Just switch the hypothesis and the conclusion. And that's what I want you to write down here. Switches, hypothesis, and conclusion. Just switches the hypothesis and the conclusion around. That's all you have to do the converse of something. Inverse, what's this little tilde mean again? Not. So this one says, if not P, then not Q. Makes them both negative. Remember always to go back to the original statement, where a lot of you are going to make mistakes. You do the converse, and then you come down here to do the inverse, and you look back at the converse to do the inverse. No, you always go back to the original statement. So on the inverse, all it does is it switches, it doesn't switch. It negates just means to make negative, negates, hypothesis, and conclusion. So it negates both parts, negates the hypothesis and the conclusion. What's it look like the contrapositive does to a statement? Switches and negates, and that's what we're going to write down right here. Switches, if I can spell, and negates. Switches and negates. Now, if we go back up to this first example I had up here. If it is raining, then the grass is wet. Whenever you're doing inverse, converse, contrapositive, and the original statement, you're always going to try to decide the truth value of it. All right? The truth value, let's look at that. If it is raining, then the grass is wet. Is that original statement true or false? True. If it's raining outside, we expect that the grass is going to be wet, right? Now, I'm sure there's other, circumstances. Maybe Jordan's got grass growing inside of his house, or it's raining outside.
At this point, please lock all your doors. Keep your students in class. Normal teaching activities may continue during this lockdown. We just do not want students or staff out in the hallway for any reason at this time. But again, normal teaching activities may continue. So please continue with your classes. But at this point, we are in lockdown. Thank you.
So, that original statement is true.
One last thing, if you do have students missing from your classes at this point, please contact the office so that we're aware where the students are. Thank you.
I don't have anybody listening.
Don't let her in, don't let her in. Don't. Mr. Saul, don't do it.
Just let her be.
This is all Mr.
It's a lockdown because of.
What are you doing?
There ain't probably work.
He's trying to get me.
Mine doesn't work on the other door but mine. Yours might work because I used to be check to see who it was. You didn't want some gunman.
Exactly.
Me open the door for some gunman.
You didn't know we were in there.
And I could have said, go hide. It was me that was in danger, not you guys.
No, we would shut the window and do some of it.
Where would we
unlock
go?
from the inside.
Go in there, okay.
So a desk at it still.
All right, back to this. So the original statement here is true. If it is raining, then the grass is wet. What would the converse of that statement be? How would you turn that around and make it the converse? If the grass is wet, then it is raining. Good. All right, so if the grass is wet, then it is raining. Is that true or false? False. All right. If it's false, Usually, if something is false, you want to give a counterexample. What's a counterexample again?
Something,
Example, it shows that
it's not.
it's not true. So our statement here is, if the grass is wet, then it is raining. What would be a counterexample of that? Why might the grass be wet?
Sprinklers.
Maybe the sprinklers are on.
Rain.
Right? That would be a counterexample. So if you tell a statement is false, you need to be able to come up with a counterexample why it's false. The next one, inverse. What would the inverse of that statement be? What's inverse do again?
Makes it.
Negates both parts. So what would it say?
Because it is not raining, then the grass is not.
If it is not raining, then the grass is not wet. Is that true or false?
True.
True?
It is not raining, then the grass.
True.
Not always true. It's false. True.
What else? Give me a counterexample if it's false. Somebody spilled Kool-Aid on the grass. Whatever. All right.
Of course.
So that's a counterexample. Contrapositive. What would the contrapositive of this be?
Grass is not wet. It's not raining.
If the grass is not wet, then it is not raining. Now the contrapositive's usually the one that's the hardest to decide whether it's true or false. And I want you to write this down on there. If original statement, and I'm just going to put a real short form. If the original is true, then contrapositive is true. Now that doesn't always work, but about 99% of the time, if the original statement was true, which we said it was, if it's raining outside, then the grass is wet, we said that was true, then the contrapositive is going to be true. All right? That'll help you out some because with the contrapositive, when you turn it around and you put all the negations in there and everything, it makes it real confusing. So that'll help you a little bit, that if you are confused, you can't tell for sure if it's true or false. Your best bet, if the original statement was true, then your best bet is to go with true on that. Logically equivalent. Two statements are logically equivalent if they have the same truth value. So if two statements are both true, they're logically equivalent. If they're both false, logically equivalent. Nothing really hard about that. A biconditional statement. A biconditional statement is when a statement is true and its converse is true. If you get a dictionary and you open it up to any page in there, it's got definitions in it, right? All those definitions are biconditional. It'll be true and its converse will be true. A lot of the theorems that we cover this year, same idea. Theorem's true, the converse is true, said to be biconditional. We won't do a whole lot with either one of those two. All right, this you have to start writing stuff down. So make sure you turn to that, the example. I'll show you how to do these. This time they gave you P, Q, and R, but they actually told you what P stood for, what Q stood for, and what R stood for. So this first one says P, I think it's on the back of one of the pages, right? It says P and R. Well, what's P say? Good, a hexagon has 6 sides. And, remember we have that word and there. 7 plus 4 equals 15, that's R. Does the hexagon have 6 sides?
Yeah.
And this is how you should do these statements to try to decide whether they're true or false. Yes, a hexagon has 6 sides, so that part is true. 7 plus 4, does that equal 15?
No.
So that's false. So we have true, the word and, then false. Is that whole statement true or false?
False.
False, because with the word and in there, both parts have to be true for the whole thing to be true. Okay? What's this symbol mean? Oh, we didn't do this symbol, did we? Oh. On the other page, something I forgot. When you have and, that symbol. All right. The way I remember it is it looks like a what? That looks like an A, which stands for and. All right. When you have or, it's the actual V looking symbol. So what's this symbol again? And. So this says P and Q. Well, P is 5 is an integer. Is the number 5 an integer? Does anybody remember what integers are? Positive or negative whole numbers. So like -4, -3, -2, -1, 0, 1, 2, 3. All those numbers are integers. What's not included in the set of integers? Fractions or decimals. All right. So is 5 an integer?
Yep.
So that's true. And a hexagon has 6 sides. Is that true?
Yep.
This part's true. We use the word and. This part's true. What's that tell us about the whole statement?
True.
True. Just deciding the truth value of that, saying that's true. Next one, P and not Q. A hexagon has 6 sides. Is that part true?
Yeah.
And 5 is not an integer.
False.
That's false. What's that tell us about the whole statement?
True. False.
How come it's false?
Yeah.
Use the and. It's got to be both parts true for the whole thing to be true. Somebody read this to me. This D down here.
Not R and Q.
Very good. Not R and Q. So not R. 7 plus 4 does not equal 15.
That's true.
That's true. And 5 is an integer. This part's true, the word and, this part's true. What's the whole statement?
False. True. True.
2 positives don't make a negative, right? Yes.
I have a question about that C1. It says P and not Q.
Mhm.
Would it be true since it says it's not Q?
Well, when we put the not in there, remember we negated the statement. So the original statement was 5 is an integer, and we negated it, which made it a false statement.
We got negated.
All right. Go down to the next part. This is using, instead of and, this symbol, it's using or. What's different about a disjunction than a conjunction?
Only one can be true.
All right, if one part's true, then that makes the whole statement true. Again, they give us what each thing stands for. P, complementary angles have a sum of 90 degrees. Is that true? Complementary angles add up to be 90. 25 plus 100 equals 75. That's false. Vertical angles are a linear pair. If I draw this little thing right here, which angles are vertical angles? 2 and 4, 1 and 3. Are 2 and 4 a linear pair? What's a linear pair do? They make a line. Name me a pair that's a linear pair in this picture. 1 and 2, 2 and 3. So are vertical angles ever a linear pair? No. So that one would be false also. P or Q. So P says complementary angles have a sum of 90. Is that true or false? Oh, P or R, sorry. Is that true or false? True. Complementary angles add up to be 90. Second part. Remember we got or in here. Vertical angles are a linear pair. That's false. First part's true. We got or. Then false. What's the whole thing?
True.
True. Whole statement is true, because only one part of it has to be true for the whole thing to be true. Somebody read this bottom one to me.
Q or R.
Q or R. So Q says 25 plus 100 equals 75. Is that true or false? Or vertical angles are a linear pair. Is that true or false? So the whole thing is
False.
false. Don't think that two falses make a positive in this case, all right? That's not the way it works. All right, with these Venn diagrams, again, write down these three answers as we go over it. Looking at these two Venn diagrams, you can figure it out pretty quickly. How many people travel by plane and train? Be careful.
Wait a
34. And train? No, 39.
9, I heard.
9.
Is that what everybody agrees on?
No,
You true 10.
36.
No, you add every one of those numbers.
You add every one of them?
No,
Now, here's where
No,
some teachers in the past probably they didn't teach you wrong, but when you were in 3rd grade, 4th grade, whenever you started dealing with Venn diagrams, that's what they told you to do. They said, all right, which people travel by plane and train? What would they want you to do with all of them? Add them all up. Is that what we should do here? No, because now you know that the word and tells you
Both.
has to be both. Both have to be true. So Fred over here, he just travels by plane. So it's true for him there, but does he travel by train? True with the word and then a false. What's that tell you about the whole statement? It's false. So Fred doesn't fit into this category. So it's not. How many people travel by plane or train? That's when you add them all up. Now be careful and don't do what Zach did, because he said 36. What's wrong with that?
Got the 9.
Forgot the 9. Do these people travel by one or the other? Yeah, as a matter of fact, they travel by both, so 45. Gotta add them all up. How many people travel by plane and not train?
25, yeah.
25. So make sure you're careful with those Venn diagrams. They get confusing if you rush through them, even though they seem sort of easy. All right, you ready, Joseph? Truth tables. On these truth tables, not hard at all. All right, don't make them difficult. We're looking at this. This is our statement. Do we have any idea if R is true or false? How about Q? No clue whatsoever. So what we got to do is come up with all the possible ways that those two could be put together and decide whether the whole statement's true or false from that. So if I gave you a 2-question true or false test, and it was over the Chinese language, so would any of you have a clue whether the first one was true or false? Probably not. All right? So if you had to guess, I gave you this quiz and you had to guess because you were going to write down something because you're not stupid, so you think, hey, I got a decent chance of guessing and getting it right. That's better than getting a 0 for sure. What could you put down for number 1? True. If you put down true for number 1, what could you put for number 2? True. That's one possible thing you could have guessed. What's another possible thing you could have guessed?
True, false, true.
You could have guessed false, true, or true, false, sorry. Then you could have guessed
False, false,
false, false, or you could have guessed
false, truth.
false, true. Well, that's what we want to do in the truth table, is come up with all those different possible ways that these could go together. All right? So what I'm going to show you for the first column here, every single time I would just do this. True, true, false, false. 2 trues, 2 falses. That makes sense, Joseph? Now I'm going to jump over here to Q. We're matching these up. If R was true, if you guessed true on the first one, Q could also be what?
True.
It could be true also.
True, false, false.
All right? Now, if R was true, Q could also be false. Does everybody see how we're matching those up? What's this next one going to be?
Wait,
True.
True and false. So we got a true, 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 false, false, true, false, false. We're just matching them all up so we got every possible combination like we had over there. Alright? True, 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 false, false, true, false, false. We got all the possible combinations. We don't have a clue whether R is true or Q is true or false or whatever it is. We have no idea, but we know we've got all the possible combinations that it could be taken care of. Now, for not R, that's what the tilde means, not R. If we said R was true, then right here in this box, not R would have to be what? False. Same thing for this true, have to be false there.
True. True.
These two down here, true and true. Now, what you're going to do with this, we're trying to decide whether this original statement is true or false. We don't care about R then. All we care about, those two columns right there.
So, false, false, true, false.
What's this symbol mean again? And, well, for this whole thing to be true with the word and, what has to be, what do we have to have? We have to have both values are true. So on this first one, you got a false and a true. What's that tell you about the whole statement?
False.
False. You got a false and a false. What's that tell you about the whole thing?
False.
False. You got a true and a true. What's that tell you? True. True and a false is false.
So why don't you use
That's our final
the
answer.
third one?
Do what?
Why don't you use the third column?
This one over here?
Yeah.
The only reason, why did we put the R in this truth
So you can
table?
do the.
So you could do the not R. We didn't have the R in the original statement. We had not R, but we
There's
need
a
to
lot
get
of
it.
in there.
Right, we put it in here just so we could come up with the not R. So what percentage of the time will this statement, this thing didn't switch on me. What percentage of the time will this statement right here be true? 25% of the time. And 75% of the time it's going to be false. So if we had to bet on this, which you should never gamble on it, but if we had to bet on this, you'd probably want to bet that it's going to be what? False.
Maybe false.
All right, on this one, this is the next one on there. We're going to fill in this. I'm going to give you about 30 seconds. Again, if we were going to bet on this, what would be the better bet this time?
True.
That is going to end up being true.
I would do the one that was false.
That's all your money.
So again, just going through this one more time. You start off with the first box, 2 trues, or the first column, 2 trues, 2 falses. Go over to the other one, not the one that's not R in this case. Go over to the other one, match them up, true, false is probably the way. So you got a true, 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 false, false, true, false, false. Gives us all the different possible combinations. Then we come back to not R. If R is true, then not R has to be false. In those two cases, if R is false, not R has to be true. And then we just look at these 2 columns to come up with our final answer out here to tell us whether the statement's true or false. Now, do we have any idea whether this statement is true or false? No, but do we know how it's broke down then? Yeah. All right, that was the assignment from last time. We're going to go over that here in just a second. Joseph, did that help?
I want to check it.
Maybe I want to check before that mistake.